friends. In today's lesson we're going to learn a little bit about FM transmitters. So this is a schematic for a kind of like low powered transmitter. It's an analog circuit, and so it has 4 stages. The first stage, which is around the Q12N3904 transistor. It's a small signal transistor. So that one is the oscillator. Oscillator circuit basically has that LC circuit which revolves around the inductor H1 and trim capacitor C1. And to keep it oscillating, basically we're feeding it back through C8, and the emitter of the transistor in C9 basically shorts it down so that it goes through the BE. But without going into much detail about it, how it works. So the FM modulation, basically when you apply through the audio 1 and 2 for stereo input, which is actually through the phone jack, but I don't want to go into the details of understanding circuitry. In simple layman terms is that when we simply apply an audio through the audio 1 or audio 2, we're going to actually change the the voltage that's applied through the base collector, and that is going to result in variations of internal capacitance. As junction diodes, they basically act as capacitance due to the internal what do you call that, the depleting area. But that's another thing that you probably want to look into if you want to understand I mean how does actually a diode act as a capacitance. Now let's get to the actual circuit. So I've implemented it here on breadboard. So you can see we have 4 transistors, and each transistor has some elements around it. And like I said, the first transistor is the oscillator, the one all the way to the left. That's the input, and here you get the feed from this cable, which is hooked to the jack here to the laptop, so I can send audio signal. And that gets transmitted in the air in this copper cable that's connected all the way back here. The copper cable is all the way long because that's a quarter of a wavelength. In our case, our signals are around 100 megahertz. So you can calculate the actual wavelength based on the wavelength equation. We use that formula to calculate the length of the antenna, and we only use a quarter of a wave because I don't want to go into that detail also, but you're more than welcome to research on the antenna design. The interesting thing is I have an actual oscilloscope. That's 200 megahertz oscilloscope, and right now I am set it into math FFT, so fast 40, try that in the yellow cable. So they act like an antenna for detecting signals, and because we're transmitting waves we're close enough to the source we can see, we can detect it, and there is a peak. The peak is basically an FFT. A peak corresponds to the frequency that corresponds to the oscillation or the sine function, because any function, any mathematical representation or function can be represented in a series, in a sum of sines and cosines of omega t. And when we have a signal that has only a cosine with a frequency, certain frequency, then we can see that the actual cursors I put the cursor on the top of the signal, and it's going up and down. That's because it's not very stable, because the frequency slightly jumps around. That shows you that the transmitter is really not perfectly stable. You can see it's that summit is at 92.9 megahertz. In addition to that, we can see actually another small spike. Those are actually the multiples of the harmonic. That's because we're not producing a pure sine wave. It's dirty, a little dirty. And actually filtering could improve reducing those spikes, I think. If we apply at the output before applying the antenna, if we apply multiple LC circuits, we can actually filter out. And so designing the filter is basically having to design the LC circuits at the end of the transmitter. So adding at the end a couple of LCs in series will result in basically removing the higher frequency content and the lower frequency content as well, because that will reduce their power. In any case, that's a simple setup that I wanted to explain, and that's very much it. But that's basically the schematic, the whole schematic of the different circuits. Actually, I did not use that integrated circuit, which is simply a linear regulator to reduce the input volt of 12 volts or higher to 9 volts. Right now the oscillator is receiving 12 volts, and like I explained before, for the FM modulation, actually transistors capacitances, internal capacitance, will change based on the applied voltage. So if we change from 12 volts, which is right now that's what it's receiving, to 9 volts, you can expect that the frequency that we're oscillating at will actually change as well, due to changing the internal capacitance. So let's take a look and see if we actually got the radio. Earlier I just showed how the circuit works. Now I want to see in real practice whether the transmitter is actually capable of transmitting signal radio. Let's play music from YouTube and check it out.
Drinks in 12 flavors. Hey, on your mind. You can play that game, but you win me every time. Everyone before. short to the most. Soon as my we're not dead yet. So the EHN music. We're taking a live stream. Live from the spring pockets. We're creative stuff. They know music that one. And just a couple